For day 5, we're going to work on finding the intersection of two lines in vector form. So when we look here, we're given two equations, two different forms in two lines in vector form, and we have our x, y, and z. So on this one, to get our x coordinate, we start at 3 and we add 1s. To get our y coordinate, we start at 0 and we add 1s. And our z coordinate, we also start at 0. We're not starting at 0, we're starting at -1 and we're adding 1s. Our x coordinate for this line W here, we start at 6 and we add 0t. Our y, we start at 2 and we add 4t. And our z, we start at 0 and we add 8t. Well, we have to figure out where do these equal. So our x values, where does 3 plus 1s equals 6? So that's where our x's will intersect. Our y, where does 0 plus 1s equal 2 plus 4t? And our z's intersect where -1 plus 1s equals 0 plus 8t. Well, we could set up some systems of equations here to solve, but when I look at this one, I realize, well, I can solve for s, -3. So when 1s equals 3, so they intersect when s equals 3. So we can go back and plug that in when s equals 3. In this case, x equals 3 plus 1 times 3. Well, that would be 6. Y equals 0 plus 1 times 3. 3. And z equals -1 plus 1 times 3. 2. So they intersect at the coordinates 6, 3, and 2. So the next thing we're going to take a look at is we're going to take a look at this triangle here. And we're asked to graph it. Find coordinates A, B, and C, prove that it's isosceles. And we're going to use vectors to check these coordinates here. So our first line, line AB. Line AB, to get our xy business, we start at -1, 6 plus r times 3, -2. So -1, 1, 2, 3, 4, 5, 6, that's our starting coordinate. And then we go over 3 and down 2. Over 3 and down 2. So here's our line AB. To get our line, what's our next line? We have line C, AC. We have our xy values. 0, 2 plus s times 1, 1. So we start at 0 and 2. And then we go over and up. So there's our second line. And then our third line, we have BC, which to get our xy values, 10, -3, and we add -2, 3. So 10, 1, 2, 3. We go backwards 2 and up 3, backwards 2 and up 3, backwards 2 and up 3. So looking right now, it looks like we have these three coordinates where it intersects. But we're asked to verify that using vectors. So how are we going to do that? We need to find out where does AB equal AC. So the x value for our AB, -1 plus 3r, where does that equal? 0 plus 1s. And then we can look at our y value for AB. 6 minus 2r. Where does that equal our y value over here? 2 plus 1s. And now we have a system of equation that we can solve. So we need opposites here. And s looks pretty easy. We could just multiply this whole thing by -1. So this stays the same. -1 plus 3r and this would become negative 6 plus 2r, negative 2 minus 2s. So negative 7 plus 5r equals negative 2. Add 5. So 5r equals add 7, sorry about that, equals 5. So they intersect when r equals 1. Well, now we have to plug that back in and to our AB when r equals 1. So our x value is negative 1 plus 3 times 1, which is 2. And our y value is 6 minus 2 times 1, which is 4. So 1, 2, and that looks good. That coordinate right there, it looks like that matches up. So we verified it with 2, 4. So let's check out another line. Let's say we need to find AC. Where does our AC equal our BC? AC, our x value, 0 plus 1s. And what is our y one for that? Let's see, AC, 2 plus 1s. And then our BC line, 10 minus 2t. And let's see our y value right here, negative 3 plus 3t. So, well, pretty easy one to make opposites again. We could multiply this one by negative 1. So 0 minus 1s equals negative 10 plus 2t. This one can stay the same. So if we add these together, 2 equals negative 13 plus 5t. Add 13. So 15 equals 5t, so they intersect where t equals 3. So if we plug that back in over here, we have our x value equals 10 minus 2 times 3, which is 4. And our y value equals negative 3 plus 3 times 3, which is 6. So let's double check that. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Yep. So there we have 4, 6. And this last line, so this is AB. Where does AB equal BC? Well, we have our BC ones right over here. So 10 minus 2t, negative 3 plus 3t. And let's see, we need AB, negative 1 plus 3r. 6 minus 2r. Okay, well, what should we make opposites here? Not one's direct, so let's do r. So this needs to be 6, so if we multiply by 2, negative 2 plus 6r, 20 minus 4t. So this one we'd have to multiply by 3. 18 minus 6r equals negative 9 plus 9t. So we have 16, 11 plus 5t. So we have t equal 1. Well, if we plug that in, 10 minus 2 times 1 is 8. Negative 3 plus 3 times 1 is 0. And let's see, does that work? Yep, this is 8, 0. And then the last thing it did is prove that it's isosceles. Well, let's see. If we wrote this as vector, it looks like these are the two sides. So what would be our vector vector here? 4 to 8 goes up by 4. 6 to 0 down 6. And 2 to 8 over 6, 4 to 0 down 4. Well, yes, because doing the Pythagorean theorem again, those two distances would be the same.